Right, hello. This is the third time I'm trying to shoot this video. I've moved down into my little workshop. It's tiny, but this is where the magic happens. So it should be quieter. There should still be a little bit of background noise because we live next to a busy road. But that being said, welcome to this build video. I'm going to show you how I put together the second version of the MRF. It's a lens coupled LiDAR rangefinder built around the Mamiya Press lenses. Version 1 did well, but I think version 2 has great improvements. And I haven't put together a build guide yet because life's been really busy and it takes a lot of work to put together a decent build guide and documentation. So I'm doing this instead. Let's start with what you need prepared before you start building. I think the first thing that you need to do is you take your lens cone, and of course you need to have all your parts printed, you have to have all your electronics ready, but you have to take your lens cone, and a lot of plastics are shiny on the inside, or just shiny like this one. And what will happen is when light comes through your lens, you'll have internal reflections, and you don't want that. It'll cause artifacts and shiny objects on your photos. So what I do is I use black from Stuart Simple, but I mean there are lots of other matte black acrylics out there, and I just give it 2 layers, and that's usually enough. And it's enough to do it just within the lens cone. You could also, if you wanted to, paint the inside or this part of your body, of the camera body. I haven't found that it's really necessary, but if you want to be doubly sure, paint that as well. Right, so once you've done that, the next thing you need to do is put in a whole bunch of heatset inserts. And I'll show you which parts need heatset inserts and which need some gluing as well. So let's start with the body. The body has quite a few heatset inserts. I primarily use M3x4s and M2x4s. So the bigger ones are always M3x4s, smaller ones are M2x4s. So you'll see the bigger ones, there's 2 on the base of the camera here. There's 2 on the front where the lens mounts. There's 2 on the side here where your grip mounts. And then there's 1 on the side here, which will be your thumb screw for your door. As far as M2x4s go, 2 on the back of the camera here, 1 on the side, 1 on the side, and 2 there, 1 on the front. Perfect. Then there's this piece that goes, this base plate, or this plate that goes between the body and the viewfinder. That just has 3 M3x4s. And that's that. And then your viewfinder or rangefinder housing also has a few. There's 1 on the side there, and then 2 on that side, and then you also have 4 on top. The other things that you need to do is the bottom plate that houses your electronics, or some of your electronics, your processor, that has a little hole on the side there. And I seem to have run out of magnets for that, but that magnet is too small, so I'm just putting it away. But you can see that you've got a magnet in this little key here, and you'll use this key I'll show you just now for managing your spool holders, I guess, or spool retainers. And you'll glue a magnet in there, and you'll glue a magnet in there, and then it just sits in there, and it's ready to use when you need it. Right, what else do we need to glue? I print my advanced mechanism, or part of my advanced mechanism, in a few pieces, and then I glue them together. And the big reason I do that is for strength. So we'll print each of these parts like in different orientations to make sure they're as strong as they can be, and so that they last a long time. And they're quite easy to put together. I'll just have some super glue and make sure my parts are clean and will fit together. So pop that top post in there, and you'll see it matches like that. Great, and that'll stay. Make sure it's straight. It's straight. And then this is a little thing that pin that engages with your take-up spool. And I'll just pop some glue in there. Make sure it stays, but it's a quite snug fit, so it should stay. Pop that in there. And if one side doesn't work, try the other side. I've got a trusty little mallet that's perfect for jobs like this. And there you go. Insert it. So we'll put that part to one side. The other thing is on this mid plate, or this plate that sits between the body and the rangefinder, this thing, rangefinder housing. There's a little bit there that also is printed separate for strength, because that will hold the spring for your advanced mechanism that returns it into place. And if it's not printed correctly, it breaks. So let's glue that in there as well. As easy as that. Okay, that's all the heatsink inserts. Everything that needs to be glued is glued. And what I'll do is we'll move on to the electronics next. Okay, so electronics are straightforward. A lot of it is plug and play, because I'm using Adafruit's Stemma QT connectors all over the show. There is a little bit of soldering to do. The first bit is soldering the feather to this daughterboard, or whatever you want to call it. That's straightforward. It's just header pins, solder it in, and you're good to go. The other bit of soldering is your linear position sensor. Solder those 3 wires there. Your negative is pin 1, positive is pin 3, and then your reading pin is pin 2 at the end there. And you'll see I've color-coded the wires. On your ADS 1015 board, your analog to digital converter, negative goes to A minus, positive goes to A positive or A plus, and then you can choose any one of the A0 to A3 pins for your reading pin. I use A1 because it just makes sense to me, but make sure that's soldered. That one's easy. Then there's the switch and the buttons. This one is interesting because for some reason, well, I guess I understand why, but Adafruit's feather boards, this one in particular, when you pull the EN pin low to switch off the board or the MCU, you still have 3.3 volts going through to your I2C and Stemma QT sensors. So what this switch does, it's a double throw, double pole switch, and it will pull the pin low and disconnect 3.3 volts from the Stemma Q sensors to switch it off. And when you switch it on, it will pull the EN pin high, switching on the MCU and restore power to the sensors. I'm going to put up a schematic to show you how to solder and connect these right now. Welcome back. That's all you need to solder. The other thing that really helps is sorting your Stemma QT cables out. I try and get them as short as possible. The ones I buy aren't short enough sometimes and can cause issues, so I cut them like that, and just solder them and heat shrink them. The other thing that you need to do is, these are generic OLED displays that you just buy on Amazon or AliExpress, and it doesn't have a Stemma QT connector. So you're going to bodge Stemma QT on one side to whatever connection you want. You can even just solder those wires in there, which will probably be the better bet at the end of the day, but I've just bodged it. And that's all of the electronics. Everything else is laid out here, and I'll go through it as we get to it. Next, we'll start building. Now, when I start building my MRF, I like to start from the bottom up. It's just intuitive and the best way to do things. I realize I've missed a little bit of support here. I just want to take that out. It was easy. And there's a little bit of right there. So your parts are clean. The first thing you want to do is take your switch and buttons. Switch uses M2x4, and that screws right into the plastic there. What I like to do is just take these M2x4s and pre-screw them in to the posts here. Just peek out. It just makes things easier because the space in there is a little bit tight. And it doesn't really matter which side is on, which side is off. You'll know when you're using the camera. Okay, so screw that in there. That looks good. Happy with that. And these switches are just straightforward. They pop in like that. Push them in. Oh, wait, let's take that nut. This one has two for some reason, but let's take those nuts and start screwing them in. That will hold your screw in place. You can just use this, give it a little bit more tightness. Perfect. Same with the second one. Super straightforward. Pop it in there and tighten the nut. Good. Next, you'll see that your feather just has two ports. One is for this 8-pin connector, and you just pop that in there. Make sure it's seated correctly. Looks good to me. And the other is for this ribbon cable. Ribbon cable connector is open like that. Your blue part is always towards the top. You insert it and lock it in place. Now you can seat your featherboard or the daughterboard. I like to connect the battery before I do that. A small note about batteries: the ones you buy from Amazon usually have the wrong polarity. Red is always plus or positive. Black is minus, ground. And you'll see that the featherboard actually has a plus and minus side. So when you get your connector out, make sure that when you plug it in, they match up. If they don't, it's easy. You use a little tweezer or something to just lift those tabs. You pull out the connectors and just switch them around, and you're golden. So I like to put this in before I fasten the board. It just makes things a little bit easier because it's once again a tight fit. And I switch on just to see, make sure that the board switches on. There we go. That works well. And let's put that in there. Make sure the USB-C port actually seats in this little hole. Like that. There we go. Perfect. That sounded like something broke, but it didn't. M2x4 to hold it in place, just 2 of those. Right into the plastic. There we go. And another one. Perfect. The next thing is getting the body ready and connecting this part to the body. First thing you need to do is take those little retainers, pop them in there, make sure you've got the one on the right side and the right side and the one on the left side and the left side. They just go in one way. And then that little key that I showed you, handy, you can just use that to pop them in all the way. So that's that. The next tricky thing is getting this ribbon cable all the way through, and making sure the battery wires don't pinch because you don't want to short on a LiPo battery, and just getting these wires out of the way. So I usually just pop the battery in there. It sits tight, nice and tidy in there. You'll see there's a bit of a indent here, and let's connect this. So we pop this through, and it should be quite straightforward and come out the other end like that. And voila. There's something is pinching. It is the battery. Beautiful. Now I use an M3x8 on each side to keep that in place. And it's a start of something. Next up, we'll look at the rest of the body, the lens cone, and then after that we'll move on to the viewfinder assembly. So the body doesn't have a lot of parts. I think the biggest one would be the rear door and then fitting the lens cone. What you can do in the meantime is glue in that little bar magnet here, and then glue in the matching bar magnet on each of your masks. This is the 6x9 mask. I'm just going to pop it in here so you can see how it fits. Great, just like that. The film door, or the rear door, has a pressure plate that needs to be put in place. This little edge that protrudes goes towards your film guide here. And then what you do is you'll see on this side there are 2 holes for screws as well. Take 2 M2x4s, screw right into the plastic on the door. And you want to leave enough space for those little slots to just hook in to the door. Come on. right? And that just then slides in there like that. And then you just fasten it with 2 more and 2x4s. Very straightforward. Pressure plate. Now you can actually fit your door. Snap it in. Have your little rod, aluminium or steel or stainless steel rod, depending on what you used, and just pop it in there. Great. Door's seated. You can at this time also just pop in your thumb screw that keeps your door in place. Beautiful. Let's stop here with the body, and we can build our lens assembly, and then we'll move on to attaching that to the body. And then we're about halfway there. So you've got your lens cone, and the big difference between version 1 and version 2 is we actually have a proper bayonet locking system here. The old version would have the lens seat, rotate, and then you'd hold it in place with a little screw. That could damage the position sensor that we used to couple the lens to the rangefinder, and it was just irritating. So you've got that, and you've got then these 4 rings, right? And the idea is that they all just kind of fit together, and then you have an interlocking or a locking mechanism for your lens. First part is this one with a little nub, and that nub will sit between those 2 terminators there, and just make sure that the lens locks like it should. And then there's this part here, and you'll see there's a little notch out of that, and that goes on the top. And then we screw that in place with a few, or 4 and 2x6 screws. Make sure that those screw heads sit flush, otherwise your lens will not seat. The tolerances are very small. And this is just a ring that kind of retains the actual locking ring below it. Wouldn't it be great if I could manufacture all of this out of metal and have beautiful thin parts that just fit together perfectly every time? Unfortunately, that's not our reality. We have plastic parts, and these plastic parts are different each time you print them. So yeah, we do what we can with the tools we have. All right, that keeps that in place. Perfect. The next part is this little ring here that will actually lock the lens in place. Just make sure it lines up with those 4 tabs there. And what you ideally want is in a lock position. You want all of those to line up, and the unlock position, you want all of those to line up so that when you close it, it locks. You keep this in place with another ring. It's got a little lock text on there and 2 little locating tabs. Pop it in. We're almost there. Use an M2x8 to keep that in place. Make sure it bites well, and there we go, and locks in place. Always when screwing into plastic, don't go too far. once you get field resistance, give it a little bit more and then stop. Otherwise you're going to just strip those holes. Last one. That feels good. We need to test with the lens to make sure everything is seated properly. Here's one I prepared earlier. So you've got your little lock line there. You line that up with the red dot. Make sure it seats flat in all parts. And voila. Perfect. We can move on to actually putting the lens onto the body. You need to get your sensor, your little linear sensor ready before you do this. I like to just seat it in its little hole here, its little nook. Make sure you don't break any of the connections off. I would, if I had to do this again, use slightly thicker gauge wire, but it is already done and I don't feel like soldering again today. Pop that in there and seat your lens cone. Right. You can use M3x4s for this. And I like to use my chunky screwdriver to just make sure it seats as tight as it can be. Right. You're protesting. It's all right. Happy with that. We can also just make sure that we can remove the lens. And once we've removed the lens, you need to check whether your linear sensor is actually moving freely, which mine is not. So I'll have to undo this quickly. Unseat this, but it's quite a tight fit. And figure out what's happening. That seems to be working. Let's pop it back in. It might be that when it's seated, it's not totally straight, so it seems to be what's happening. The thing you can do is just widen that hole a little bit that it peeks through. And how do we do that? With a screwdriver, or just give it a bit of leeway. It might be that there's plastic in there that just hasn't been removed properly, or it's a matter of just finagling. Oh, there we go. Is it good? That looks perfect. So let's screw this back in. Great. Let's check that's still moving. It is. Exciting. The next part we'll look at putting this middle plate up and connecting all of the electronics and getting the body ready for the rangefinder mechanism. All right, some electronics. There's this little board that's new as well, that basically just breaks out this ribbon cable to 6-pin connector for the LiDAR and a 4-pin connector for the Stemma QT sensors, and once again connect it on the blue end here towards the top and just twist it around like that. It sits in there, there's a little nook for it, and screws right into the plastic again with 2x4 screws. I think what we can also do is the advanced mechanism here. So let's look at that before we get into the electronics proper. You've got this ratchet mechanism, and make sure that when you insert it, when you match your advanced gear there, that it seats like that. Because when you turn your advanced mechanism, you want it to go in that way, but not the other way. So pop it in there, take your advanced gear and pop it in there as well. That's good. Then there's this plate that is used to keep it in place. And that sits there and is also kept in place with 2 M2x4s. Easy, easy. Okay, I'm gonna put this out of the way for a bit, and we can get back to it when we screw more into it. You'll see there are holes in here, and they are for mounting your ADC board, as well as your MPU 650 accelerometer slash gyro that is used to show you your level lines, which are very handy when you're shooting landscapes and panoramas. They are built in a way that their wires have enough space to route, and they will fit like that with their connectors. What I like to do is I'll take one of these little short ones that I made, the Stemma QT connectors, and with your plate like this, with where the advanced mechanism will be facing to your right, I like to put the accelerometer board here, and then we'll take the sensor board, the ADC board as well, and put that here. But we want to connect the cables between them before we do anything else. And we also want a longer cable, because this will go into the rangefinder housing. And we connect that to that side and pop that through there. Because that'll sit there. And I'm going to screw this in. Once again, straight into the plastic, M2x4. Give it a bit of support from the back, because these tabs can be quite flimsy, but they do the job. When I'm building my own camera, I usually just use 2 screws, but let's do things properly today and use all 4 screws. And I know I keep saying this, but don't overdo it when you're screwing right into the plastic, because you're going to regret it and you'll need to reprint your parts. Great, that's sitting in there. I'm going to connect another slightly shorter cable to one end of the ADC sensor here. And what I also want to make sure is that when I seat the ADC sensor, that where these connectors are, where you've soldered your wires into, needs to be in where this little gap is. Give it some room to breathe. So let's connect this one up. And we'll give it another little wire here. We're connecting to some other parts in the rangefinder housing, and pop that wire through there. And let's screw that in place. More M2x4s. If you're wondering about the orientation of that board, make sure the text faces up. Orientation of the other board doesn't matter because we're not measuring anything depending on the direction of the camera with it, like we are with the accelerometer. Okay, one last piece of advice I can give you is your LiDAR sensor, that wire also needs to be routed under this board. So take the wire you use for that, thread it through this hole here, and then connect it straight to the Stemma QT. Oh, sorry, the LiDAR socket on that little breakout board, like that. What I also like to do is add an additional Stemma QT cable in here, because that will go straight up into your rangefinder housing from here, and just pop that in there as well, like that, and pop that through there. All right, so now you've got all of your wires, and we can put the stop plate on, being careful not to pinch any wires, routing your wires in a way that makes sense. And once again, make 100% sure you don't pinch anything. I seem to be okay. Go from the top and make sure that everything is... Oh, it looks like I'm pinching that little blue wire there. Let's get that out of the way. Maybe not the right tools. Tweezer would do a good job here. Got one somewhere. There we go. Right, so that sits nice and snug now. And what you need to do is screw this plate in place with our friends M2x6. So once again, 2 at the back, 2 on the sides, 1 in front. The one on the side is actually, you may find that an M2x6 is too long for it. So you might need to use an M2x4 there. Let's see, I'm going to try an M2x4. I can see the heatsink insert right there. Yep, that sits nicely. Perfect. Front one here, I'm going to use another M2x6. Oh, that fell out. Let's try again. Nice. Almost there. It's just this little guy on the side, and you can see it's quite close to the plastic there as well. So I'm going to use an M2x4 on this side as well and keep that in place. If I can get it in with my shaky hands. Let's try again. Perfect. That's your body. The body's almost ready to put the viewfinder housing on, but we first need to mount all of the electronics in that housing, and that's what we'll do next. Okay, before we get to the rest of the electronics in the rangefinder housing, we actually need to just sort out our advanced mechanism. So take your little door spring, and that hooks in to that little slot there. You should have a little piece like this. Oh, almost didn't have it anymore. A piece like this. That's also keyed. That will basically just slot over your advance post here and click into that little hole there, and that just keeps the spring in place. When I was talking about heatset inserts, one place I missed was on the bottom of your advance lever. That also takes an M3x4 heatset insert, and that just takes an M3x6 screw, because that's where your spring will hook onto. You can just hand screw it in there. Then your sprag clutch is a bearing that basically just goes one way and locks in the other way. The direction for me is quite easy because I know that this plastic bit or this translucent bit goes inside and the metal bit is exposed to the outside. Yours might be different. Make sure that your direction is correct, otherwise you might break your advance post. So you'll see it's keyed on the inside and outside. Just line up the keys, pop it in there. The same for this, and that means it's the right way around. So when we actually get to mounting the top plate, you'll just have to make sure that your screw actually hooks onto your spring. Like that. So we'll put that to one side now and get started on the electronics for the viewfinder. Right, let's put the viewfinder together. Start with the optics actually. So you've got a beam splitter, 30 by 30 millimeter beam splitter. Make sure that's clean. There is a right side to have towards this end and the right side to have it towards that end. I haven't been able to tell what the difference is just by eye. The way you usually know is when you've got your beam splitter in and your OLED display bounces off it and there's a bit of ghosting, then you know it's the wrong way around. Just open things up again, take it out, rotate it around. That goes in there. It pops in there. You've got two lenses. One's a bit bigger than the other one. This one has seen some things because it's been in and out of cameras all over the show, but it still works wonderfully. Big lens goes in the front with your concave part facing in towards the camera. And that should just slot in there like that. Your smaller lens has a concave and a convex side. Make sure that the one that bulges outwards faces in towards the camera, and pop it in there. All right, we're all good for our optics. Yeah, that looks good. Next, I like to do the OLED and our light sensor. OLED first. That goes in like that, where your ribbon is protected behind that little post there, and it screws right into the plastic, like so many other parts with M2x4s. There's only 3 screws for this. You'll see where they go quite easily. Just like that. Orientation of your light sensor doesn't really matter. Pop it in there. You'll see there are 3 or 4 screw holes. The 4th one behind here is quite difficult to get to. So I actually just use 3 screws, and that seems to be enough so far. But if you want to go to the trouble of screwing in all 4, be my guest. Alright, those are seated. Take your other short little Stemma QT cable and connect those 2 together. Making sure not to break those very delicate connectors, like I have so many times. Right, all that out of the way. Next thing I think that would be easiest is our rotary encoder. That has a nut and a washer. The washer stays on here. You'll see that this board from Adafruit has an LED there, and there's a little hole in the plastic there. Just line those 2 up, pop that in, and then on this side you screw in your nut. I just use my screwdriver to tighten it. I don't have the proper tool. I should probably get the proper tool. I mean, I've been building enough of these. I probably build more of them in the future, but for now, this approach does the trick. Then I take my secondary display and I'll just pop it into its little hole there, hidey hole. And that just seats there and stays there all by itself. I like to connect that to the outside socket of the rotary encoder, like that. Should have a piece like this as well, and that is to keep your LiDAR sensor in place. And things are getting exciting now. We're getting closer to the end of our build. Bring back your body, grab your LiDAR sensor, and it slots in just like a little puzzle piece. Ooh, put that in there. Yep. See, it's in there. Bit fingerprinty, but we'll get rid of that in a bit. Then this piece I showed you a few seconds ago, you'll see that inside there's a little slot, and that literally just slides in and seats in there. Might be a little fussy, but with a bit of patience we'll get there. Oh. My fingers feel really stupid today, but well. Oh, there we go. Almost there. And that just slots in there, and then there's a little hole for an M2x6 that will just keep it in place. I'm using the wrong tool here. Curious why that didn't work. Right. This little Stemma QT cable that comes from the accelerometer pops through here and just plugs into the other side of the rotary encoder. Like that. This one that's coming from a little breakout board plugs into the light sensor. Like that. And then lastly, this one coming from the ADC board plugs into the display. And that's all of our wiring done. Now the tricky bit is tucking these wires in here so that they don't pinch when we put things together. There's loads of space. Don't be afraid of just tucking them all in there. Same with this. I'll just pull all of these wires through here. Same with our little LiDAR sensors wires. They can just duck in here as well. I just want to take this off so I can make things a little bit easier for myself. And there we go. Put this back on. And now when you put everything together, make sure that you don't pinch any wires, and I'll keep saying that, and that your hook on the bottom takes your spring. I'm just going to do this the other way around. Okay. All right. Let's pop it all together. Of course, the other difficult thing is going to be to make sure that the direction for your rotary encoder and the key in that post also lines up. Right? Oh, it's not the most difficult thing, although it seems to be today. There we go. Tuck all our wires in. I think this is the most irritating part of it all. It's just getting all of these wires out of the way. I think if I would do this build again, I would just make sure I've got a bunch of short wires to make it easier for just them to stay out of the way. Because you really don't want any wires pinching unnecessarily. I've got some here that are pinching. I could literally just tuck in here, but once that's done, that looks good. Happy with that. Now you'll see there are 3 holes for M3x4 screws. So let's screw this housing in place. Good. That is very satisfying. Okay, so what I'd like to do before I put the lid on is switch the camera on to make sure that everything's getting power that should. And you'll see, got a little green light there, there. If I look through it, I've got power and a display. I've got power and a display there and there. I'll show you in a separate video how to flash the firmware. And I would recommend doing that before you put the board in or before you put the camera together, because it's a good way to test that everything is working before you close it all up. We know it's working, we can switch it off. We can tuck our wires away neatly. And then we can put our lid on and do a few finishing touches. All right, so lid just slots on like that. It's tight fit. Good, cool. I use M2x6s all around. That way I know it all seats properly. Wrong tool again. Start with this little bit that's sticking up. This isn't screwing into the plastic, it's screwing into heatset inserts, so you can give it a little bit more go. Be careful though, because these cheap screws, or these small screws, the head can literally break off, and then you've got a screw stuck in your heatset insert. And guess what? That means you need to reprint the whole part, because there is no neat and tidy way to get those out without damaging the part. Guess what I'm trying to say is, for most part, just be gentle, and you'll get there eventually. Was too short. Great, happy with that. We almost have a shiny new camera. The only things we need to do is add a few niceties. 2 of them, a couple of them. The first one is a cold shoe for a flash or whatever you want to use on there. Mine came with these irritating little hex screws, and that just screws right into the plastic. I might have a future design where there are heatset inserts, but I found this works perfectly well. Just screwing right into the plastic, as it bites well, and you've got that. The other thing is, and I need to find it here in my little of it is one of these guys that allows you to screw a tripod into your camera and have it on a tripod. The bottom of the lens mount, pop in a bit of super glue to make sure it stays. Give it a counterclockwise rotation first, and then to make sure it's seated, and then there you go. And then we can screw it in to the plastic and it should sit. So there are some middle bits of hardware on this camera. I'm going to use, I don't have a tool here. Usually I would use a butter knife, but I don't have a butter knife here now. So yeah, let's just screw that in, maybe with the back of a tweezer. If I can find one. I've got one. Oh, that works well. Please don't look at the state of my tweezers. I use them for everything except what they should be used for. Alright. Screw that in nice and tight. The super glue will make sure it doesn't rotate out when you're actually using this on a tripod. I think that's it. It's in there. Perfect. Look at that. You've got a shiny, new, modern rangefinder. And it's going to help us keep these wonderful Mamiya lenses alive. So let me clean this lens on both sides, and I'll put it in and lock it in place. There we go. That's locked in place. It might feel a little tight at the beginning, but the more you use this mechanism, the easier lasers will slot in and lock in place. Make sure all of your little shiny surfaces are clean and fingerprint free. And there you go. I like to use peaks, little strap lugs with this camera. Let's do that as a finishing touch. All right, there you have it. And the finishing touch is your grip. This is an interesting one because you need to finagle your screwdriver through that hole and screw it in place. So what I like to do is I use the longer screws, M2x8s here, and I pop one in each hole. Whoa. You wouldn't believe how many screws are in my floor. Let's just take another one. Great. And then you just line it up. Pop your screwdriver in there. Line it up. And screw it in. Same with the other one. and you can make sure that they are nice and snug. Awesome. Grip done. Thanks for spending some time with me. This is the camera. It's called the MRF2. All of the files are open sourced. They're all available on GitHub. There's no build guide yet. It will probably come in time. For now, this video is the build guide. Contribute if you want. Improve it. You're allowed to build as many as you want. You can even sell it if you want to, if you want to go that route. The license allows for that. But yeah, I just like to see people building the stuff I design. So reach out if you've got any questions or if you need any help. If you've got ideas to improve this, let's work together and make it a better camera. Yeah, thanks for watching. There'll be a separate video where I walk around with the camera, take a few pictures with it, and I'll show you the pictures. I'll talk about using the camera, calibrating the lens, and give you some tips and show you some sample photos. So see you soon. Goodbye.